All right, everybody. I want to talk about photosynthesis a little bit. And if we're going to do that, we need to start with a plant cell. This is a plant cell. There's two different kinds of reactions that happen within the plant cell. We talked about these before, the light reactions and the dark reactions. These are oftentimes referred to as the light dependent because they require light to operate. The dark reactions, sometimes we call those the light independent, often referred to as Kelvin-Benson cycle. Within the plant cell, there's a structure called a chloroplast. It's an organelle. That's where the chlorophyll is. It's housed within the chloroplast. What happens, light shines down on this. It's the sun with its majesty. And the wavelengths of light, the energy, comes in, the photons, and it strikes the chloroplast. The chloroplast then takes that light and it gets housed inside some electrons, like I was just talking about in the previous part. Okay? Those electrons then bounce out to a higher energy level and they're held there, they're captured there. So now that energy coming in from the sun has now been captured in the locality, literally the physical position of an electron that's housed within a bond. That energy is then used to take a molecule of water, split it between oxygen and a proton, a hydrogen ion. So as this is happening over and over and over and over and over again, right, the hydrogen ion concentration of that chloroplast starts going up and up and up and up and up. Okay? The electron is not lost. So we took some of the energy out of that electron once we had it, and we put that in to split some water. Then we send it over along the surface of that chloroplast to another location where it's hit by even more light, and then it's captured into a molecule called NADPH. Here's that electron right there between the phosphorus and the hydrogen ion. Right? So that electron was energized by some light. It split some water. It was re-energized, and now it's stored as NADPH. What happens with this hydrogen ions, now that it has a high concentration inside of the chloroplast, it flows through, there's a different color, the enzyme ATP synthase. Hydrogen ions flow through and ATP is produced. So the energy that's captured by sunlight coming in and interacting with the plant, with the chloroplast, is here in NADPH and here in the form of ATP. There's an actual diagram in the textbook which you can look at that shows you this in a little more detail. It looks like this. So if you want to go into a little more detail with it, you can see here's some light coming in right there, and there's some light coming in kind of right over here. It's hitting these structures called photosystems, and photosystems are really nothing more than collections of enzymes that are engineered to do this work of grabbing onto these wavelengths of light. Here you can see kind of near the bottom, the water molecule is being split, it's kind of directly over from my finger here, into the hydrogen ion and the oxygen's kind of being just released off into the environment. And you can see those hydrogen ions building up in that thylakoid space. This is what they're calling the inside of this, the thylakoid space. It flows through that ATP synthase molecule, and those protons are released to the outside of the thylakoid, and the ATP is produced. Up here at the top, though, you can see where those electrons kind of bounce through the cytochromes. They get hit by light again, and they bounce up to actually ultimately get placed over here into that molecule of NADPH. And as you can see over here and from down here on the bottom, both the ATP and the NADPH are then sent over to the Calvin cycle, aka the Calvin-Benson cycle, where they're going to get used to actually make some sugars. And all about that in the next video. Thank you.